Hey guys, Robert with 3D Printscape. So recently I've been playing around with trying to figure out how to get a stronger part without using more filament, and actually I'm trying to reduce the amount of filament I'm using. So I was looking at a couple options. Option one is adding an additional wall on the perimeter, which has been my typical go-to in the past. Option two is increasing the infill line multiplier. So basically, if you're doing a grid, it will double the thickness of the wall on the grid, therefore increasing the strength overall and using less actual filament than it would going up to a higher percentage. Alright, so what I ended up doing here for a test, which I'm going to be finding out the results here with you, is I printed out 7 parts. Basically 3 parts at 5% infill, one just 5%, one 5% with the one wall, one 5% with the double infill. Did the same thing for 10%, and then I have one at straight 20%. And what I want to do is figure out if there's any strength difference. So in order to do this, what we're going to do is I'm going to jump over to the computer, kind of show you what I did in Cura really quick so you can see what the parts are going to look like and how to actually set those up. And then I'm going to come back here and we're going to put some pressure on these parts and then actually take a couple measurements to see if the infill differences actually does make a difference. Now I'm just going to be using a wood clamp here. I was looking for other options. I know a lot of people on YouTube have been doing something similar for putting pressure on it. One of these days I want to get a hydraulic press to be able to actually press these parts. I just haven't been able to get my hands on one yet, at least not for a decent press. And then I'll be using my calipers here to actually take the measurements. Alright, so let's go ahead and get started, but before we do, if you haven't already, make sure you hit that like button and subscribe. Thanks. Alright guys, so I got Cura up here. I'm just using my standard profile. I kind of wanted to go through what I'm doing here for this experiment. I printed 7 blocks total. They're just 20 by 20 cubes. I'll link to the cube that I used in the description below, but layer height is just basically 0.2, and I remove the top layer so that if I slice it you can actually see in. So I'm going to do that really quick as an example. You'll be able to just see straight into it and see the infill. For the test, what I did was I printed 3 blocks with a 5% infill, one 5% with a normal wall count, one 5% adding an extra wall, and one 5% adding an extra multiplier. Then I did the same thing at 10%, and then I printed one at 20% as well. Alright, so let me show you what that looks like. So right now I've got 5% selected, but if I wanted to add another wall, I'm just doing this. I'm just switching it from 2 to 3. And what that's going to do is it's going to, it'll use a little bit of extra filament. At this point, we're only talking about 3 grams of filament here, or 8 cents. So it's not that much of a difference, but it does add up over time based on the number of prints you do and or the size. But if I go over to preview, if you look here, you'll see that I added a 3rd wall, which that's my typical go-to if I'm trying to add additional strength without adding any more infill. Alright, so let me go ahead and revert that, and then let's show you what it looks like here if I add an additional multiplier on the infill. So if I go to infill line multiplier, if I switch that from 1 to 2, it's basically doubling the thickness of the infill. So you can see here there's 2 right basically side by side versus it just being 1. If you look down here, it's basically the same print time at 22 minutes and using 3 grams of filament, but it's slightly less on the distance, so it's somewhere between 3 and 4. It's not precise with the estimates here, but it's close enough. And it reduced the cost from 8 cents to 7 cents. And that's factoring about $26 per 1 kilogram roll. And then if I switch this back to just the 1 here and slice it again, it's going to use a little bit less filament, but I think we're going to see that the strength is pretty significant difference. And the difference between these is about 1 or 2 cents on the actual cost of the filament and about a minute or 2 on the print. And then I did the same thing with the 10% infill as well. As you can see, the infill looks pretty different. I'm still using the cubic infill pattern, but I'm going from 5 to 10%, so we're doubling the infill, and that puts it back to about where it was with 5% but double the lines. And then if I jump up to a 20% infill here, we're going to see a pretty big jump in print time and cost. 20% is about as high as I go for most of my prints. I try to go with lower and just increase the wall thickness, but I really wanted to run this test to see if it actually made a difference by just switching the infill, because it does use a little bit less filament and then adding additional wall, at least for this. But it is worth going between the two to see what makes the most sense for the print that you're doing. Don't assume one is necessarily better than the other. All right, so here, we're going up to 24 minutes on a 20% infill, then we're using 4 grams of filament. So we're basically talking about a gram of filament difference. With a small print like this, it's not a huge deal, but like I said before, if you're really looking at printing larger or printing a lot of quantity of parts, that definitely can add up quick. All right, so now for the fun part, let's go ahead and take a look at these parts and see if the actual infill differences make a difference here. Again, the only thing we changed was the wall thickness on one of them and then the infill multiplier on the other one. I have a feeling that the infill multiplier is actually going to provide a stronger part, even stronger than it would be just by adding the extra wall count, but I haven't actually run this test, so I'm going to be finding out the results as you are. Alright guys, so we're going to start with the 5% infill. I'm expecting this to have the most give, obviously due to the least amount of infill, but we'll start with the 5% infill just by itself, 5% with the extra infill multiplier, and then 5% with the extra wall. The first thing I want to do here is just go ahead and get my initial measurement, which is going to be 20.06. And then we'll go ahead and grab this, and I'm going to put it so that the top of the part's towards the bottom. That way it's putting the most pressure on the part, just about midway through. Then I'm going to just push it tight and then give it 3 full presses, and that should give us a decent reading. Anything more than that, I don't know if the part or the actual wood clamp will hold. All right, so 1, 2, 3. All right, so 5% infill, 3 presses, didn't hold up well at all. So I'm just going to count that as a complete bust. So 5% infill will not provide you much extra durability. All right, so now we're going to test 5% with the extra infill multiplier. I'm not sure how big of a difference that's going to make it to 5% just because of where the actual infill parts are. But let's go and get the initial measurement. We're at 20.13. And I printed these parts pretty quick. Wasn't trying to get them accurate. I was just trying to get them for testing purposes here. All right, so I'm going to bring this back. I'm going to do the same thing I did last time here. Go ahead and put it so that it's about midway up. And I was originally only going to do this test with the 10% and then the 20, but I thought it would be fun adding in the 5. And so far, it's proven to. All right, here we go. Let's go. 1, 2, 3. All right, so we definitely have some compression here. You can see it a little bit from there. So what I'm going to do here is just get the distance from here to here now, and then subtract from the 20.13 that we had. All right, so we got 18.87, but at least it survived. All right, now let's go ahead and do the next one. I'm going to get my initial reading. This is the 5% with the extra wall. And that's at 20.03. All right, then we'll go ahead and set up the test again. All right, right there. And then go 1, 2, 3. Now we'll go ahead and measure the difference again and see if it had an impact or not. All right, 18.72. All right, now let's jump up to the 10% and do the same thing. So this is straight 10% here. We're at 20.15. So here we go. 1, 2, 3. 18.68. And then I'll go through all of the results once I actually subtract them all out here in the conclusion. But so far, it's looking like the 5% infill with the extra wall and multiplier both held up better and used less filament. All right, so here we've got our 10% infill with the infill multiplier. So 20.12. Now I also want to make a note here, I'm paying extra attention to make sure when I'm putting this in here, I'm smashing the same side that I measured, just in case there is anything that's off-centered. All right, and 1, 2, 3. I'm having a hard time actually pushing that in. So what do we got here? 19. All right, so we got 19.37 on that one, and this one is the 10% with the extra wall. So let's get our initial measurement. All right, so initial measurement's 20.08. All right, then we'll go ahead and run our test here. All right, so 1, 2, 3. And we got 19.34. All right, now for our constant, or what we're testing against. Here's a 20% infill, no modifications. So let's go ahead and get our initial reading, 20.19. All right, and then we'll go ahead and run our test. All right, so we go snug. And then we got 1, 2, 3. And then we got 19.64 on that. All right, so now I'm going to go ahead and run our numbers really quick and then wrap it all up. All right, guys, so I went ahead and ran the numbers, and the 20% infill had a difference of about 0.55 millimeters under pressure, and the best result I was able to get with the 10 millimeter was 0.74 under pressure, and then 1.26 with the 5% infill under pressure. So we couldn't quite get to the numbers that the 20% infill is able to get you, but if you look at the infill multiplier on the 10%, it used about 25% less filament, printed in about the same amount of time, and was reasonably close on the strength. And then if you take it to adding the extra wall, which is what I have typically done in the past, it got slightly stronger by 0.01, and it used the same amount of infill, but it took an extra 2 minutes to print. So it's really what makes the most sense for the part that you're printing. Increasing the infill or adding the extra wall did make a substantial difference. As you can see on the 5%, it actually made it so it can actually withstand the pressure versus the one that was just 5% where it completely shattered. So overall, if you're looking to save on filament, seems like the best bang for the buck is going to be adding the additional infill multiplier. It's going to get you a quicker print and use right around the same filament as the extra wall. That might vary based on the part you're printing, so it might be worth running the rough numbers in Cura so you can see the time difference and see what makes the most sense for you. But in most cases, going with a 10% infill and an extra wall or an extra line multiplier is going to be strong enough to meet the needs, and still almost as strong as a 20% infill part, which is my standard typically if I'm just doing a normal fill. So it kind of makes you think about things differently. So yes, you can get stronger prints by increasing the infill, but that's not the only way. You're going to want to play with the infill multiplier, the pattern type. If I was trying to get the strongest infill overall, I would have used gyroid instead of the default cubic, but I was just going with what most people will default to, which is the default setting in Cura for this test. But if you have any questions about the test I did or would like to see any other tests be ran, go and leave a comment below or join me on Discord. Thanks.